season for hurricanes, and then another hurricane, and I'll show a little bit of that today. Now, part of NASA's Earth science has focused on the hazards. What we've been doing a few years is once you start going beyond the natural Earth system, which is what NASA studies, to include the entire Earth system, including humans and our impacts, you really get into disasters. And that's what I'll try and get to today. Now, at any given time, we are monitoring the planet. We're monitoring the planet 24 hours a day, 7 days a week. And so we can see the nature of events that are stirring. Like right now, we are monitoring the volcanoes in Indonesia because they've been particularly active. And we keep an eye on them and find out if anything spins up. Obviously, we're very active monitoring and finding out what's going on in California right now with wildfires. GPM, the Global Precipitation Mission, is a particularly valuable tool for us. It shows us when many of the storms are coming in. So as you look through last summer, we could see the precipitation and the evolution of the different events and the tracks of the different hurricanes coming in. As Harvey came in and went through the Gulf, we weren't sure where it was all going. Working with the Weather Service and various others, we saw the stalling over the Gulf and then finally impacting an incredible event throughout, Texas, one of the largest flood events throughout the region, and called upon all of NASA's scientists who are across all our agencies, centers, partners around the world to understand what was happening. And soon after that, Irma came barreling through the region. We were monitoring where's the rain, what are the impacts into the Caribbean islands, and as it swooped up the coast, followed by additional hurricanes, and eventually, by the end of the season, one of the ones of greatest impact, the stories in Puerto Rico, which I'll focus on a bit today, is Maria, that's just starting to spin up. Now, we can see it from rainfall. We can also see it from aerosols and clouds. The types of events that we are looking at complement what's been done in weather services. It might say that there's storms and rainfall, but we can see it from a number of different phenomena. So as the winds, the clouds, the aerosols, the dusts also are good signatures of the types of events that are spinning up across the world and across the region. At any given time, we're monitoring those. And so we had Harvey, we had Irma, we had Maria, and they all had characteristic impacts and characteristic differences. Now, that told us a lot about the hazard science, but when this issue about getting to disasters really showed up, for example, if you now take a look at the night imagery, not only were we monitoring the day, but we're monitoring at night. At night, we see people, we see cities, we see communities, we see the impacts now that these three events are interesting from scientifically, but when we now say, what is the effect on people? We saw immediately these signatures in Puerto Rico, lights on, lights off. This was the most dramatic impact that people saw in science that were really trying to understand what is the risk, what are the impacts of risk. This was a wake-up call for many people who saw pictures of terrible disasters, but they didn't know the scope and scale of what was happening. These types of pictures and this type of imagery and its interpretation was particularly useful. This was what it had looked like on the Washington Post, where they said this looked like before Maria, 8 days later, and hey, we can start to see recovery. The recovery observations, that's something inherently new. We often talk about early warning for the disasters, but people are looking to us, NASA and our partners, on what's the type of information that will really tell us when we're starting to recover and recuperate from these events. The NASA Disasters Program mobilizes all of NASA's science and NASA's partners around the world, globally, to answer key questions. We support the actions that people are taking before events and preparedness and mitigation, after the events for recovery and response, and we establish those partners before, during, and for the sustained duration of events. We care about people, and so the idea that we're monitoring the planet, but the idea that we can see during a storm not only where the events are happening, where the land is changing, where the storms are impacting, but now overlay layers of where are the people. And perhaps the people that live within a few meters of the water tells an entirely different story than just seeing the precipitation. So we work with not only the physical science data, but the socioeconomic data sets. We're working globally to locally, harvesting the right data and getting it to decision makers. This little set of pictures is actually a storyline. When the Louisiana floods started to come in, those global precipitation missions started to tell us how the storm was hitting and where the rainfall was happening. People were starting to mobilize, moving sandbags, relocating themselves and others and their families. At the same time, we were starting to go out and capture available optical data, the available synthetic aperture radar, as well as tasking around the world to get additional data sets, turning that into maps and models about where was the water, where's the floods, where are the impacts, where are the damage to property, feeding that into decision makers, both on the civilian side and the defense agencies. When the Hurricane Harvey hit just recently, it's not just, we often hear talks about what data, but it's the right data at the right time to the right people. So on August 23rd, we had the first indication of a serious event was starting to occur. NASA develops what we call a tier 0. We suddenly come together, we rally all of our partners to find out whether we have information, we have data, and then we start trying to respond, whether we're working with the Army Corps of Engineers or the National Guard or FEMA or state and local officials or academics, providing information about the nature of the storm, turning that into information products and tools about damage, flood extent, the impacts on communities at the community scale. As we get into it, additional questions start coming in about what's the resolution that these storms are starting to percolate over days and weeks and months. New questions start appearing. So we bring in new assets like some of the airborne flight. Insurance sectors trying to understand how do I go from rainfall to actually a risk map that tells how much loss in reinsurance. And then where are those impacts day and night? Who's available? And even for the responders coming into the region area, providing them safe and secure information about what they're dealing with. A few weeks later, Irma, again, another storm, complementary set of information. Not only do we observe the planet, but we have global flood maps, global modeling that occurs in partnership with people around the world to provide the models, the data, again, turning into relevant types of community models and maps about winds, water, storms, the percolation, and again, into the communities. The season wasn't over, yet another event. Maria, we know the direct hit on Puerto Rico, and as you saw, going from the rain, the storms, the damage, the power outages, the power recoveries, and then the damage into neighboring islands. NASA worked not only with Puerto Rico, but with World Bank, with many others, to see the entire Caribbean area. So mapping what was the state in Dominican Republic or Bermuda, what was going on throughout the region and other parts of the world. When I talk about NASA answering questions, there are forecasts, there are information that people have that are provided routinely. But the NASA team, which represents every NASA center and coordinators across, and all our investigators, get these really simple questions that require really advanced science. How much rain has actually fallen? To be able to answer that question, we have to mobilize a number of people in very complex communities of practice to develop the rainfall, our models, and getting it to, for example, the Red Cross, who are now going to activate and take actions for the right communities. It could be another question about social and economic impacts, so where we're trying to provide information. When Harvey happened, to my surprise, they were calling on NASA and our partners to bring in not only what's where the storm is, but what was the population of people being impacted. NASA has socio-economic data that they overlay and mix with our earth science information. And then often our information also enhances the media and the communications, telling the story to help people take the right type of actions. The electrical power companies were not only trying to figure out where generically the power was, but specifically where was the power outage, so they could pre-position their information. And our black marble products, the day-night vision data that's coming in, is becoming an incredibly new tool to connect the Earth observations to people and impacts and the teams that are responding. How large is an event? That's a question that comes in all the time, whether it's a volcanic plume that goes up and people want to know how large is that plume and how far is it spreading around the planet, whether it's a flood, the flood extent here or the flood extent in an area of another country, or whether it's a wildfire in South America, this time in Argentina this year, one of the largest wildfires in the history of the country. The questions were the same. What's the extent and the impact that's happening? And we were using a large variety of partnerships, particularly with our radar, to provide the extent and the damage information. This question about where exactly are the lights out? Over the last few weeks and months, this day-night imagery, the black marble, has gotten down to the neighborhood scale, down to 30-meter resolution to the scale where we can actually start to see the lights on and lights off on the street level. What's the damage of insured loss? Here, using our radar data in Mayagüez, Puerto Rico, to try and see where particular buildings have been lost and flooded and subsidence has happened. An interpretation with the insurance brokers to develop these insurance loss maps, which go into not only insurance, but the reinsurance, which is the what are we going to do to rebuild decision. Now, the interesting thing about Harvey was that one of the largest events in the history of the country. 4 large river basins. Never in the history have we seen 4 river basins all flooded simultaneously. The amount of water hitting Texas was going to take 12 days to drain across multiple cities, towns. Those cities and towns could evacuate. Houston was going to be the recipient of all that water. All that water, Houston couldn't evacuate. Houston had to figure out how to deal with that. And eventually that water was going to go into the Gulf. The question was, how is that water cascading across Texas? We had satellite imagery. River gauges were actually overflowing. The gauges were underwater themselves. We worked with the state partners. We brought in airborne assets. We identified the areas. And so we matched questions of flood extent with the evolution of the floods. Not only do you have to know where it's flooded, you need to know where it's dry. You want to know those areas that are still above water. So looking at the end of August to the beginning of September, areas that were immediately flooded but were soon after dry, that told people where to bring in logistics or where to evacuate to. This is all done with partners, partnerships both in federal agencies, local agencies, academics. NASA responds to, as I said, about 100 events a year. Typically, we call out and rely on every partner. When we responded to Nepal just a few years ago, we didn't immediately know who to work with, but we called upon our partners in the cryosphere community who work routinely in the Himalayas or in the high mountain areas. If we're dealing with floods, we're working with hydrologists and engineers, officials and local communities. So partnerships are a key thing. Partnerships mean that our information, our data, our science gets exercised and actually gets used, and we get feedback on the quality and the value of that work. So we were really busy with these hurricanes, and then all of a sudden, 2 earthquakes. So now we mobilized our teams to look at earthquakes and the landslides and the risks and the subsidences that were happening. And in this case, we had the first earthquake, which didn't cause too much damage. It didn't cause too much loss. And the second earthquake just a few days later was actually a smaller magnitude, but a much larger impact. And so we were working closely with partners, FEMA and the equivalents in Mexico, to provide the information, the maps, the risks, the practices. We have a website where we track all of the events and provide this information. We rally together to get everyone's information up in a common place. And over this year, we're building this not into just a plain place just to find information and pretty pictures, but it's tools, it's analytics. We're working with the geospatial community to get really geospatial analytics and tools. So now you don't just come to AGU. I always tease our team and say, oh, that's a really nice picture. It'll make a great presentation and poster at AGU. But we want to go further. We really want to turn this into science tools and science information products. So that's where we are. And I'm glad to give you the update, information on where to find us. And just by being here and being interested, don't be surprised if we call on your involvement in the next disaster response or research activity. Thank you.